Okay, so let's look at the mathematics associated with osmosis. In dilute aqueous solutions, the osmotic pressure, which we use the variable pi, can be calculated. Pi is proportional to mt. Now, I just want to say this pi, this is not the number 3.1417. This is just a variable, like I'd say x. But they use the Greek letter pi as the variable. It's not a number. So we can say pi is proportional to the molarity of the solution times the Kelvin temperature. And then we can say, well, pi then is equal to mt times some constant, which I will call r, and r happens to be the gas constant. So we can rearrange this in the popular form, pi equals mRT. Pi is the osmotic pressure in atmospheres, m is the molarity, units of moles per liter, r is the gas constant, and 0.0821 liter atmosphere per mole Kelvin, and T is the Kelvin temperature. Now, what does this remind you of from Chem 111? PV-NERT, PV equals nRT, and we know PV equals nRT, and N is moles and V is liters, so P is equal to N over V times RT, and N over V is molarity, right? Moles per liter. So we're just looking at that in a different form. So let's look at the first type of problem that would be the absolute easiest, simplest kind you would have. What is the osmotic pressure of 0.010 molar aqueous solution of a molecular compound at 25 degrees C? Well, a molecular compound, it doesn't matter what it is. And when we go ahead and look at this, this is where we just write out the equation, plug in the numbers, rearrange, and solve. We know that the pressure, pi, is equal to mRT. So the only thing we have to do here is to adjust the units. So when you look at this problem, what's the first thing we do off to the side before we can put anything in the equation? Change Celsius to Kelvin. You never plug Celsius temperatures in. So the Kelvin temperature is equal to the Celsius temperature, 25 degrees, plus 273.15 Kelvin, so we get 298 Kelvin, stopping in the ones place. Now we plug and chug. Pi, the osmotic pressure, is equal to the molarity, 0.010 molar, moles per liter, times R, 0.0821 liter atmosphere per mole Kelvin, times the Kelvin temperature, 298 Kelvin. So the osmotic pressure, pi, is equal to 0.24 atmospheres. So that's as straightforward as they get. Now, the next one that I have for you to try is a little bit fancier. I would call this problem easy. This next one is medium. And the reason it's medium is you're not just plugging and solving for one of the variables. You're going to solve for the molarity, and then you have to do something to convert that to grams. So let's have you just do this one at your seats.